Hey everyone, sorry I'm late. I haven't had a chance yet to look over your tests, but I'm gonna try to get them back by next week. Maybe by Thursday. Okay. So today I want to move forward in the book a little bit, and I want to start chapter 9, and we won't spend too long on chapter 9. It's going to be about stuff with inequalities, and how to solve it, not using the approach that we learned before with kind of interpreting an absolute value inequality as a problem about like a distance from some point, but we're going to do it kind of the standard algebraic way. And you'll see that it's, if you think about it, if you break down the pieces of it, it can actually be really simple, even though the pieces that are make up an equation could be more complicated. So as long as you break down, you realize that it's a complicated looking problem that can be broken down into simple parts, the section is a lot better. Okay, so let's start. And we'll also do a little bit of just word problems, kind of how to read a word problem and set it up as inequality, because I think that's also a valuable skill. We did word problems with equations, but we'll do some word problems with inequalities just to kind of see how those things can work. So I'll go here. I'm just going to pull up. Chapter 8. By the way, what did you guys think of the test yesterday? Any thoughts or comments? I know a lot of you had questions about the determinant stuff. Yeah, go ahead. Somebody's going to say something? Nice.
I think it was pretty good. I just need to have a bit more practice with the determined aspect.
Right. Yeah, that's fair. It's kind of like definitely something you have to memorize how to calculate them. Nice, Gabrielle. Awesome. And I realized that it was actually my bad. I should actually, for the next test, what I'll do is I'll try to make it like, I'll give you a practice and then try to make it like, so that you take, push you guys to set aside some time to take the practice, and then grade yourself. And I'll post like the answers and see how you do, and then you can kind of try to gauge how you're doing. Because I think for this one, I felt like a lot of students, you guys, many of you kind of knew like what the pattern was for the determinant, and then possibly once you got to the test, you're like, oh, wait a second, which happens a lot. So that's why I think it's next time we'll do a little bit more practice, right, just before. Okay. And maybe we could do like an in-class, like 45-minute test, and then we can go over it immediately. So you're kind of forced to actually sit there and try to solve things that you might not know how to do. Okay, so let's go to some questions from 9.1. So we're going to start to chapter 9. So let's see, what do we have here? Yeah, so I'm going to do a simple example here, example 1, and we're going to do it in 2 different ways. So this is inequalities and applications. So here's a simple example. And we're going to do it 2 ways. We're going to do it with by algebra and also graphically. So solve the following inequality. This is example 1. And this is straight from the book. So this is solve 2x plus 4 is less than negative x plus 1. So if we want to do using algebra, anyone want to volunteer what we should do first? And what a kind of a general strategy with algebra is?
Get x onto one side.
Perfect. And what's the only difference between solving inequality and regular equation? What's the only thing you have to be careful with?
The like greater than like less than sign.
Uh-huh.
Like when you divide by a negative, it changes.
Exactly. It's you have to be careful with if you multiply by a negative, or one other thing is you want to avoid multiplying by an x or dividing by an x, which is generally something you should avoid when you're having an equation, because that x might be 0, that can mess things up. But in particular, the only difference is if you divide or multiply by -1 or by a negative number, you switch the sign. So this is same kind of approach as solving for x, except be careful multiplying or dividing by negative numbers. Oops. We'll switch the inequality. And by the way, can anyone explain why this happens? Like, so if you have, if A is less than B, why do we know that negative A is greater than negative B?
Since such a great change will flip it over 0, so then it would have to be switched.
Yeah, yeah, exactly. That's one interpretation. Um, Another way you can see it is just if you try to get this as you can rewrite this as well as 0 is less than b minus a, and then subtract the b over, you move it over, you get negative b less than negative a. So these are exactly the same inequality. And it's exactly like how Archer said that, you know, if one number is less than the other, then the negative is going to be actually like less big than the negative of the other. So that should be greater. Awesome. Okay, so this is just something we'll be careful with. But in this example, solving for x, we can add x to both sides. My strategy for solving inequalities is because I know I can forget flipping the inequality sign. I'm just gonna maybe get confused, and I generally don't like dividing by negatives because I have to remember to be careful. I like to always make my coefficient in front of x positive. So I would probably add x to both sides on this one. So this, I'll write it here, 2x plus 4 less than negative x plus 1. If I add x to both sides, I get 3x, and then I subtract the 4, so I get 3x less than negative 3, and then I divide the 3, I get x is less than negative 1. And if you want to write it as an interval, you could write it as negative infinity, comma 1 in parentheses. Any questions on this way of solving it? Okay, let's do this another way, which is a graphical interpretation, which is nice for other types of problems where maybe the graphs, maybe you don't want to really do algebra, but you want to understand like the visual. Later in math, you're going to be, would it be -1 instead of, oh, that's right, thank you. Sorry about that. It's going to be -1 here. That's right, because it goes all the way to, here's -1. And now let's hang on here. Negative x. Yes. Yeah, so you could write it like that. So it would be this set right here. Okay. So the other way that they set it up is the other way they set it up is by looking at the graphs. So you can think of this as f of x, where this is the graph of, this is f of x here. These correspond here. Has to be less than g of x, which I'll write in here. And so you can that's right, it'll be open circle there. Yes, so good comment. So it'll be open circle right here. Good. So if you do f of x as less than g of x, well, first you have to graph what each of these are. So the first one, f of x equals 2x plus 4. Well, we know the intercept is going to be at 4, and we know it's going up by 1 over up 2. So it's kind of like, it's going like that. You know, it's just a rough sketch. So this is going to be the red line. And what's the slope of the green line, or of g of x? Nice, it's -1, which is the coefficient of this one. And the intercept is at 1. So this one goes it starts over here, and then it goes over 1, up 1, like right there. So it's going down 1, over 1, if you want to think of it that way, because it has a slope of -1. Oh, let me change the color, so make it green. And if you look at the picture, if you're doing a better job with the graph, you'll find out that the place where it intersects is x is equal to -1. That's kind of the intersection point. And you would get that if you actually set them equal to each other, and you can find the intersection point. Okay, now from the visual, when is the red line, for what values of x is the red line less than the green line, lower than the green line?
Sorry, repeat.
Yeah, for what values of x is the red line beneath the green line?
Beneath?
Yeah, because we want f of x, the y value of f of x, like the y value for f, to be less than the value of g. And
wouldn't it be from -infinity to -1?
it's the same thing, exactly. Do you see that, Archer? That this, I'm just asking kind of like, when is this line less than the green line?
Yeah,
So,
I just got up a bit. Yeah, that makes sense.
and so this is a visual way of interpreting inequalities, saying like, when is one part of the curve lower than another part of the curve? So that's visually what it means, which I think is nice to have. It's nice to have the algebraic technique where you just isolate everything and say, okay, this is the answer. But it's also nice to visually see, oh, this is talking about like when, like, that's why inequalities come up in the first place, because you might want to know, if you have a graph of two functions, you might want to know, okay, when is one part of the curve underneath the other part of the curve? Something like that. So yeah, very good. So the region where it's going to, red one is underneath, is going to be here. So this region. Okay, and that's the same as before. So we have, I'm going to use the set builder notation here. This is the set x such that x is less than -1. And actually, I'm going to erase these. I don't want to, because later we're going to do something else with these. Okay. And over here, I'll put an open circle. Are there? Yeah, I probably shouldn't shade it. It's just here. I'm just purely asking about the X area. You're gonna shade stuff. We will do some problems with shading, but that's when we say that the Y value has to be greater than some green, like some f of X or something. So I shouldn't shade at this for this problem. The answer here is just a one-dimensional part on the x-axis. Just some answer about the number line. Later we'll do something where it's a little bit more complicated. Okay, let's do a word problem. And again, the math here. Do you guys feel pretty comfortable with like the algebra and the math here? Please hit yes if you feel like it's pretty straightforward, and no if you have any questions as well. Okay, nice. Looks like about half the class hit yes. Very good. So what we're going to do next, usually when I did this in person in the class, I remember about like half the students, like the math that you guys agree is straight up. Yeah, let's do one more example. But we're going to do an example now that mixes in with a word problem. So this will be, or Yeah, let's try another example. So this one you guys do on your own. And I'll wait a few minutes for you to give me the answer. So solve this one. You can solve it algebraically or graphically or both if you have time. Solve negative 3x plus 1 is greater than or equal to x minus 7. And just chat me the answer privately when you're done. All right, nice. Awesome. Gabrielle, would you mind sharing what you got?
Yeah, sure. I got x is less than or equal to 2.
Nice. And how did you do it?
I started out with subtracting the 1 from the equation on the left,
Uh-huh.
and I got negative 3x is greater than or equal to x minus 8.
Awesome.
And then from there, I subtracted the x. So that would equal negative 4x is greater than or equal to negative 8.
Mhm.
And then I divided negative 4. And because you're dividing a negative on both sides, you have to flip the sign.
Awesome, you got it.
So then the outcome of the answer would be x is less than or equal to 2.
Excellent. Right. Thank you, Gabrielle. That was awesome. Wonderful. So it looks like a lot of students got that. Are there any questions about this example? And if you have your book, you can see they approach it also. It actually said in the book they wanted you to solve it graphically. And you can see they draw the two graphs and they think about when the one on the left is greater than the one on the right. And it's the same answer. Oh, yes. You can do addition. I would personally probably do addition because, like I said, I don't like dividing by negatives. So you could also have done it 8, adding the 7 and adding the 3x. You could do it like this. And then that would give you that 2 is less than x, which is the same thing as these are the same. You flip the sign whenever on both sides you either multiply or divide by a negative number. That is the key. And to avoid flipping the sign, I really don't like flipping the sign. This is my personal preference because I know I can forget it or get confused. I just try to anticipate that. Okay, I'm going to try to make sure that whatever I have in front of x, because that's what I'm going to divide by at the end. I just try to make it positive. But if you're comfortable with the flipping part, that's totally okay. Okay, let's try a word problem. You guys did great on that one. Let's try a word problem now. So the method that's going to be required for the word problem is the same as kind of what we just did, maybe with some decimals or something, but the equations are the same, but it's just the key is being able to set up a situation expressing it in terms of an equation. So this is example 4. And I really like this type of example because it's something you will actually might consider if you ever go into the workforce and you have to say, okay, well, let me write it out first, and then I can ask you guys if you have know what these terms mean. Some of you might have seen these terms as well. So after graduation, Jessica has two offers in sales. So there's Uptown Fashions. Which is a salary of, gives you a salary of $1,500 per month. Plus 4% of sales. And Ergo Designs, let's call it Ergo. This one gives $1,700 a month. Plus a commission, and I'd say plus this one's also a commission. Plus a commission of 6% of sales in excess of 10,000, 10K. No. Okay. So I'll let you guys read this for a minute. Can anyone kind of tell me, or have any of you ever worked any sales jobs, or yes, that's a good question. What does excess of 10K mean? Can anyone volunteer to explain like what is a commission for a sales job? And have any of you ever worked any sales jobs? Nice, Lily, you're in now. Nice. That's a sales job. Do you get any commission? No. It would be awesome if you got commission because they do a lot of business. But what is a commission? Does anyone know what a commission is? Anyone know a type of job that has commission?
Do real estate agents?
Nice, real estate, exactly. And yeah, do you want to elaborate on that? How that works?
Don't they get a certain percent of like the house they like sell?
Exactly, yeah. So if they sell, a $500,000 house or something, they'll get a like no matter how big the house is, they get a percent of it, which is pretty awesome. So if you sell a really expensive house for doing basically the same work, you get a lot more money. But I guess it's harder to sell a really expensive house because there's not as many buyers. But yeah, real estate is a good example where there's commission. Oh, nice, the judges on Shark Tank. Yeah, Maddie, what do they do? How does that work?
Basically the people pitch their ideas and then the sharks are like, yeah, that's good. I'll take some of that money too.
Right.
And then I'll give you this in return or whatever.
Yeah, they do a few interesting things in the Shark Tank. How many of you, just a show of hands, how many of you have watched the Shark Tank? Awesome, nice. I really, it's a great show. One of my favorites. It's really good. Yeah, so it's a little bit different than like a commission-based sales position. So they're investors, so they take a percent, but they do charge. They sometimes take something called royalties. So they'll own part of the company, but especially like the bald guy, Mr. Wonderful, and some other ones too. They like to take a piece of every sale back to themselves, and that's called the royalty, in addition to owning part of the company, like a stock in the company. So sometimes they get a really, really good deal like that. So yeah, so real estate is a good example. Car sales, anybody who works in car sales usually works on commission. Does anyone know how car sales people, I don't know if they still do this, but does anyone know how they would work? So usually for like somebody's working, there's jobs that are a mixture of like salary based and commission based. Also, insurance and financial products, you also get a commission if you sell those, which I don't really recommend getting into that business too much because it's a very high churn. Like not very many people succeed at doing that. It's kind of a brutal work. But yeah, so the way it works is you join these companies and they pay you like a very low salary, but there's an opportunity to make a lot of money because if you can sell a lot of the product that the company sells, you get a percentage of the total sales. So you can add to your salary by doing a really good job. So based on these two jobs, what are the pros and cons of uptown fashion?
It doesn't pay as much as Ergo.
Mm-hmm. And what about the commission?
Pays more, but you have to get like the commission instead of having like the like Uptown one has like constant commission while the other one has to be of excess of 10K, if I'm like saying that correctly.
Exactly, right. So in the first one, if you sell 5,000, oh, sorry, in Ergo Designs, if you sell like $7,000, like anything below 10K, you're not going to make any commission on that. But after that, you do get commission on the stuff that you sell above 10K. Okay, so a natural question is, there's only so much you can sell at one of these jobs. So Jessica might want to know, which job should I take if if I'm expecting to have some amount of sales, can I calculate which job will actually pay me more money? So let's try to set this up. So let S be the amount of sales. The question is, find out for which amount of sales is Uptown Fashion's better pay. Okay, so also somebody mentioned Starbucks, which is really good. They do have a pretty nice employee program, I think, where they give you some stock, and I think they also pay for school as well if you work there long enough or something. I heard something like that. Okay, so what do you guys think? What equation could we set up here? What inequality could we set up to solve this? Anyone have any thoughts? So kind of just focusing on Uptown and Ergo, which one do we want to be bigger?
Uptown?
Uptown. So let's just do like a really basic thing. Uptown pay is greater than Ergo pay. Okay, what's the formula? What's an expression that we can write down that would represent the amount that Uptown pays in a month, assuming that you have S sales? So you might have to use some stuff we did with percents and decimals a little while ago. So what's a really simple expression we could use that for that one? Awesome, Lily, nice. So we could do you want to explain that idea?
I did 0.04 for the percentage X
Mhm.
plus 15,000 because it's per month.
Nice. You have 1,500 here plus, and I'm just going to use the letter S because I introduced that as S, as sales. But you can use X as well, totally okay. Awesome. All right, now ergo is a little bit tricky. Anyone want to, and you can either message me in chat or just raise your hand. Anyone want to try to explain what expression would be good to give us the amount ergo would pay?
Is ergo the 1,700 then the? I don't really get the 6% sale in excess of 10K. Would it just be the same where it's the 0.06s or?
Almost. So okay. So you okay with, I agree with 1,700, right? That makes sense. But we want 6%. But let's say the sales kind of, it's always helpful to work out like a really concrete example. So imagine the sales were 15,000. What would we do to that 15,000 to figure out the commission? For ergo.
Would it automatically be the 10K that it's getting times by?
Well, you get, so if it's 6, you get 6% on sales of excess in excess of 10,000. So you have to read that as whatever you sell above 10,000, that's what you get to get commission on. Below 10,000, you get no commission.
7,000.
What was it?
I mean 700, not 7,000.
Oh yeah. So if there was if somebody made 15,000 in sales, you would subtract the 10,000 from the sales and then multiply that times 0.06.
So would you just do 0.06 times in parentheses like 10,000 minus X or X minus 10,000?
X minus 10,000, exactly. Okay. So let's see here. So yeah, this represents an excess. This is the amount. These are the sales in excess. You see this many times for different types of like plans, like cell phone plans or data plans. Sometimes they'll say, you know, the first, you know, it used to be with text messages, maybe like the first 200 texts are free, and then every text after that is like 5 cents per text or something like that. So you have a lot of situations where like, or contracts where there's some amount that there's one cost, and then after that amount, you have another cost. And the trick is to just say, okay, well, the amount that's greater than some threshold, you can just subtract off that, and that whatever number that is, that's what you would work with. Okay, now let's try to solve this. I'll give you guys a few minutes to try to solve it on your own. And my hint here is, you know, yeah, be careful with decimals, but this is doable, I think, without a calculator. And message me when you get an answer. Hmm. All right, I'm getting a few different answers here. I'm curious to see those. I'm going to ask somebody who didn't get it exactly right. If you because a few people made some errors here, so I just want to see if I can spot the error and we can work through it together. Charlie, would you be okay to kind of walk us through what you did?
Sure. So I got rid of the 150 on the left side by minusing it to
Good.
the 170 on the other sid.
Nice. Yeah. Okay. Good. So we got 0.04, and don't forget this extra zero, so it's 1500. So did you get 200 here?
Yeah.
Awesome. Okay. What did you do next?
And then I multiplied the 0.06 times s and then times that by the 10K.
Yeah. What is 0.06 times 10K? What's a good way to do that? Yeah.
Yeah.
Nice. I like that. Okay. I think you were actually really close. I think I see what you did. Okay. Where did you go next?
I think I know what I did wrong too.
Yeah.
And then did you get negative 400 because of 200 minus 600?
Uh-huh.
And then I accidentally added the point instead of
Oh.
subtracting it.
Nice. So if you subtract it, you get 0.02, negative 0.02s is greater than negative 400. Awesome. Good job catching your mistake. Sometimes you see like sometimes just redoing a problem from scratch can help you catch the mistake. Okay, and what do we do from here? What's a good way to handle this type of arithmetic?
Did you divide the negative 0.02 both sides?
Yeah. One little thing that I like to do, because sometimes it just freaks me out to divide by decimals like that, is I try to turn everything into whole numbers. So maybe multiply everything by 100, just to make it, a little bit easier to be more comfortable with it. But you don't have to. You can just divide everything by negative 0.02 and get the answer. But if I'm doing it by hand, I might say, okay, this means that this is going to be negative 2s is greater than negative 40, and just add two zeros. That gives me 40,000. And then say, oh, okay, that's not bad. So s has to be less than 20,000. Excellent. Where did the negative 400 come from? Oh, yeah, good question. So when Charlie distributed the 0.06 into the 10,000, you got negative 600. So combine 200, the 200 minus the 600. Oh, okay. Yes. So you don't need to do what I did with the 40,000, but I did this thing where, you see the 0.02 here? You could divide everything by 0.02 and just get the answer. But for me, like, I always get nervous when I divide by decimals, just because I'm worried if I'm moving the decimal the right way. So one thing that can make your life a little bit easier when you're working with decimals is try to get rid of them. So you can multiply both sides by 100. To get rid of 0.02, you multiply by 100. That'll just make it 2. But if you multiply 400 by 100, you get 40,000. You don't have to do it this way though. You could immediately divide by negative 0.02. That's totally fine. Okay, wonderful. Thank you guys for volunteering. Let's move on to, okay, so we have some stuff, let's see. Yeah, we actually did already 9.2. That was domains and intersections. And we actually already did 9.3 with absolute value inequalities. Let's see. Oh, so I'm going to do, let's look at some things with 9.3. There's some more complicated situations with absolute value inequalities. So let's see here. So I'll show you one. Let's do some stuff. So 9.2 is about domains, intersection, and union. And so we had discussed those ideas earlier. So we're going to skip that. Maybe I'll assign some homework, but it should be familiar. So now let's look at some absolute value equations. So this is 9.3. This is 9.3. Let's say example 2. Example. Let's say example 4. So they say the following. Solve absolute value of x minus 2 is equal to 3. So based on what we learned earlier, what do you guys think? Not exactly 1. Let's maybe draw it out. Nice. Yeah, 5 works. Is there any other answer? So let's do it the way that we did earlier. Nice. -1 also works. Olivia, can you explain this using that distance, like the English way of doing, the English sentence way of doing it?
The English what?
Like you remember like the sentence, like the distance from this is this, and then you can draw a picture.
Oh my gosh, yeah, okay, hold on. I kind of forgot. So isn't it like the distance between x and -2 equals 3, or is it like it's something like that, right?
Very close. How can you fix that up? You're super close. It's the distance between x and, why do you say -2? If you have two numbers, how do you find their distance?
Oh yeah, you like define their average. No, you like divide. I know what I'm saying. I just can't. I can't put it into words.
If you have like, just think about two simple numbers, like 3 and 8. How do you find how far apart they are?
You subtract them.
Exactly. And then, but you want to take the absolute value because maybe I'll switch it on you and say, oh, what's the difference between how far apart is 8 and 3? So you might, it shouldn't matter how you say it. So based on that example, you were so close. What is this? What's a good translation of this? The distance between x and what should follow this?
Would it be 2?
It's just 2, exactly, because the minus sign tells you to like measure how far apart they are. If it was x plus 2, remember that we did that thing like it would be x minus -2, then it would be the distance between x and -2. But if it's just the absolute value and there's a minus sign there, then it just means this is how far apart those two numbers are. Is equal sign, it means is 3. Awesome. Okay, so now how do you draw this? What's the point that you focus on in the middle? What's kind of like our home base or the middle point? Yeah, 0 is good. Not 3. 2, 2, exactly. 2 would be the middle number. Because we want to say how far away is x from 2. And this time they say it's not less than 3 away, it's actually exactly 3 away. So if we add 3 over here to the right and 3 to the left, then you're going to be at 5 and -1. So those would be your two answers. Excellent. Any questions on, I know this is maybe we did this a few weeks ago, but I'm glad that we got to review it a little bit. Any questions on this idea? Okay, let's try to do this now algebraically, so not drawing with the picture. You can almost always do these. Is there a way algebraically where you? Isn't there a way? Yes, exactly. That's right, Lily. So in this chapter, we're going to kind of try to do more of the algebraic approach, and it's up to you which approach that you like more. Sometimes I think the algebraic approach is a little bit of overkill for like, you know, if I just saw this equation, I just think about what it means and say, oh yeah, then obviously it's going to be -1 or 5 if I see once I see the number line. But when the equation is more complicated, maybe I don't want to think about some weird fractions and like adding, subtracting some weird radius from a fraction. So okay, so with the algebraic approach, we have to think about, we ignore whatever is in here. In this case, it's not that complicated, but if we have an absolute value equality, we have to say, okay, so whatever is in there, it can even, in order for the absolute value to be 3, there's always 2 possibilities. So I'm going to write this key idea. Absolute value equation or inequality is always secretly 2 equations. So this is just a key thing to remember if you're doing it algebraically. You always want to be setting up 2 separate equations. And the equations you can think of are, well, imagine this is just an expression, just a number. How could this absolute value of this number, what are the possibilities to make this number have absolute value 3? Well, there's only 2 possibilities. That number inside, which is x minus 2, it could either be equal to 3 or x minus 2 could equal to -3. And if you solve this, this tells you x is equal to 5 or x is equal to -1. Can anyone tell me, first, give a yes, please, if you are comfortable kind of with why the x minus 2 could be either 3 or -3? Right, those are the only things that satisfy absolute value of something equals to 3. Those are the only possibilities. Okay, can anyone explain what this or, should I write the word or here or the word and? Or is there no difference? And this is where we have to be careful with English versus math. So Gabriel, there are two equations. So there's two answers, but it's a little tricky, this thing. So and in the last chapter, last section which we skipped, but we did earlier, or represents kind of the union of possibilities. So just kind of write it on the side. Or is a union and is an intersection. This is in math, like in math speak. So if you say, okay, I want the students to take English or math, well, then you group the two classes together and you pick, you'd have a set of students that take either class. If you want the students that take English and math, then you would take the students that are taking both classes simultaneously. So if I say I want x to be equal to 5 and I want x equal to -1, even though those are the two answers, the word and, is there a number that's equal to 5 and also equal to -1 at the same time? So if you say and here, it's technically going to be incorrect, because that would mean that there's nothing there, because there's no number that's 5 and -1 at the same time. So we want to use, when we have multiple possibilities, we want to use or. But when we want both conditions to be true at the same time, we use and. So obviously, if there's multiple, like actual, like individual multiple answers, we would use, it could be this, or this, or this, or this. We don't want it to say, we don't want to use the word and here. There are cases, though, that we will use and when we want to say, okay, it has to satisfy this condition, and it also has to be, has to satisfy another condition. Okay, let's do one more example. This time we're going to have two absolute values. Let me do here. Okay. This is example 3. And this one I'm going to just show you a little bit of, like, there's a little bit of math speak in here. So given that f of x equals 2 absolute value x plus 3 plus 1, find all x for which f of x is equal to 18. So yeah, take a moment to read this. Does anyone know, like, what a simple equation is that we could set up here to solve it?
Could you put like the 18 in the x thing, like of the f of x for 2 absolute value, substitute, thank you, Gabby, for telling me that. Like substitute 18 for the x in the first equation?
Perfect, exactly. Yeah, so this is just a fancy way of saying, okay, find when that expression f of x is equal to 18. A lot of times in math, they like to ask the question this way. So given the function, for what value of x is the function equal to some value? And then all you do is just replace f of x with that specific value. Nicely done, Olivia, thank you. So it's like this. Okay, now what do we do from here?
We can subtract 1.
Nice. We can do subtract 1. This would be 17 is equal to 2x, 2 absolute value x plus 3. And if you want to get the, it's nice to get the absolute value by itself, so then you can set up the equations easily. So now divide by 2, 17 divided by 2 is 8.5 is equal to absolute value x plus 3. And if you want to do it algebraically, it's nice to just think, okay, now I got to split this up into 2 equations. So what are the 2 possibilities for x plus 3? The thing inside the absolute value. And by the way, when you do this, you never do anything to the expression inside the absolute value. It's just going to be equal to 2 different possibilities. Never change this number, if there's a minus sign, I see people sometimes change it to a plus sign or something like that. You just always rewrite the same expression here. I think that's a nice approach to take. I've seen other people say, okay, make everything in the negative, set it equal to 8.5, but I don't like to do that. I like to just say, okay, this x plus 3 has to be the same, but it's what it equals to that can change. So what are the 2 things that it could equal to? It could be 8.5, nice conjugate, 8.5, and then negative 8.5. By the way, you could have just as well do this, the distance from negative 3 has to be 8.5, and you can do it with the picture that we did earlier. All right, and now you just solve this, you get, and there's an or here, by the way. So you can get x is equal to either 5.5 or x is equal to negative 11.5. Any questions on this example?
Compared to matrices, this is much easier to understand.
Yes, yeah, definitely, yeah. Matrices won't be on the final, but just a question. Did you guys, anyone get to watch some of the 3 blue, 1 brown stuff? I really like his videos. If you haven't had a chance to watch it, I recommend checking it out. The really cool thing about that subject, about matrices and linear algebra, is you don't need any advanced calculus to kind of move really far in that subject. So if you know basic kind of like algebra and arithmetic, and you understood some of the concepts that we like solving a 2x2 system, and what a vector is, that's basically all you need. And he goes through all of it in his videos, which I think is really cool. So it's neat because it's a subject that you can get into without a lot of prerequisites, and it's a really, really useful subject to learn about. But I agree. We did some pretty abstract stuff. But Archer, and any other students, did you guys feel like you kind of got a nice understanding of a simple 2x2 matrix, like how it represents a transformation? Nice. Yeah, so as long as you have that, that's I think a really nice idea that matrices are really just a way to talk about algebraically moving vectors, moving the entire grid around. Okay, so let's do one more example. This time I want to show you guys a type of problem where this is going to be example example 5. So this will be the last example here. Solve 2x minus 3 is equal to x plus 5, absolute value. Oh, does anyone know somebody named Sean Walton? There's somebody in the waiting room, but I don't know who they are. Okay, well, oh, they left the waiting room. Or maybe they'll change. Maybe they're using somebody else's Zoom account. Yeah, so let's try this example. So in this case, an absolute value has to equal another absolute value. So there are two ways for absolute values to be the same. Either these numbers, whatever they are, have exactly the same sign. They definitely have to have the same value. So either they're the same number, so that's one possibility, or the other possibility is that they have opposite signs. So they can either be the same number, or they can be opposites. So if they're the same number, then it's really simple. You just get rid of the absolute values and just solve directly. 2x minus 3 equals x plus 5. Or alternatively, you can say, oh, okay, well, if they're opposites, then that tells me 2x minus 3 has to be the opposite, negative on the outside of x plus 5. And notice I didn't just put the negative, I don't just make this a negative here. So I take the whole expression and I make it a negative. Are there any questions on how I got those, like the logic behind getting those two equations? Okay, please move forward and try to solve these and then message me what answers you get. And I'm just going to write it down here. Oh yes, Gabrielle, so definitely the first, so whenever it's absolute value equals absolute value, right? The only way for that to happen is either the things inside are the same, or if they're opposites, then that would also make it true. Okay, nice. I see a few students got the same answers here. Awesome, great. All right, are there any questions on this example? Oh, let's see. Kanji, do you see? Yeah, be careful here. I see a few people that got 2 as well, or -2. Don't forget to divide by the 3. Oh yeah, yeah. Let me walk through the equation. Okay, so were you comfortable with the idea that this equality with absolute value equals absolute value of something else? The only way that that can happen, I always focus on what's inside, and I'm just going to treat that as an entire thing. So either those two things are the same, that would make it sense. That would make this true. So if they're the same number, or if one of them is, let's say, positive and the other one, they have opposite signs. It doesn't matter which one is positive or negative, but the point is that whatever one of them is, the other one has to be the minus of it. And then it's just two simple algebra equations, right? This one is really simple. You add 8 and subtract x, you just get x equals 8. Here you do have to be careful. You have to distribute the minus sign. So I jumped some steps here, but the negative x gets moved over here to make it 3x. And then here's negative 5, but you add 3, that gets you to negative 2. And then lastly, you just divide everything by 3, and you get that. Alrighty. I will post some practice for you guys to do these. These are, as Archer said, much easier, I think, than some of the matrices, especially like the 3x3 determinants. I think a little bit more down to earth here. And I think on Thursday, if you want to move ahead a little bit, you can take a look. We're going to talk a little bit about 9.4. And then I would like to start chapter 10. And chapter 10 will be kind of what we work on up until Thanksgiving break. By the way, does anyone know when is Thanksgiving break?
Next week.
Ours starts on the 20th, I think.
So okay, so you don't have school no school that whole week, right?
I believe so.
Yeah.
Okay, cool. So yeah, so then that's perfect. So we'll do a little bit, and I do want to get you guys set up on exponents and radicals, so maybe you can kind of try to do some of the homework, you know, if you have time during the break. And also, please, if you guys want, you know, because we're off from class, if you need to do any makeups, it would be possible, because I mean, I'm just at home, so it would be possible to do a makeup during the break, but you need to submit, tell me that you've like uploaded your corrections, so I can review them and kind of give you some feedback and see if you're ready for a makeup. But please, if you see that some of your test scores are not as high as you would like, make sure that you stay on top of that, because you don't want to be doing that. You know, I think I want to set a deadline maybe by before winter break. I want to make sure that you have taken all of your makeups. All right. And then the class, the final will be like January 20th or something. So we'll have a little bit more material after the winter break. But up till then, probably be just chapter 10, and yeah, probably just be chapter 10, I think. Alrighty, guys, I'll see you tomorrow. Have a wonderful rest of your day. If anyone has any questions, I'm happy to stick around if you have any questions about your practice tests or.
Bye. Thank you.
Bye. See you guys.
Mr. Minsky, so I'll be taking the test on Thursday, right? After class?
Yeah, perfect. Wait, all right, yes, did you email me? Let me see. Yes. Let me see. Yeah, let's do Thursday after class. That sounds good.
Okay, thank you.
Mm-hmm.